Hey folks, my name is Chuck Black and we are explaining things related to software, and today's topic is PubSub. What is that? Well, that's what I'll be explaining in the next few minutes, so let's get started. So let's talk about this thing called publish subscribe, the software design pattern called publish subscribe. Before we do that, really quick review of what we've been talking about in terms of our software design patterns. We talked about loosely coupled design in our situation with Quokka Prime. Because we have at the center of all of this RESTful API, it allows everything to be loosely coupled. This host monitor can be written in Python, as I've done. I've also written versions of the host monitor in Java and Go. Likewise, could be done for all of these things. These things down here, the user interface, they could all be written in different languages by different people at different times because everything is loosely coupled. If everything was jammed together, then we wouldn't be able to do that. But because we have this RESTful API, loose coupling allows us to do that. The next thing that we looked at was separation of concerns. Basically, I don't highlight anything in red because fundamentally everything is in red. This service monitor, what does it do? It monitors services. It's not concerned with the user interface. It's not concerned with the database. It's not concerned with these diagnostic functionality. It does one thing and it focuses on that one thing. The same thing with all of our other monitors, the same thing with our port scan functionality, the same thing with our user interface functionality, as well as this server service that is running. They do one thing, and the idea of separation of concerns is you focus every one of your modules on one thing. It allows for many different positive outcomes as a result of that, including the ability to easily maintain and enhance your code. So separation of concerns, very important thing in software development. And that brings us to publish subscribe. It's also known as PubSub. You may hear people saying this. What is that talking about? It sounds like a different language. Really, all it is saying is that this is a software design pattern where you implement things using a mechanism where a single entity is going to publish an event or information, and there will be multiple listeners or subscribers who are listening for events of that type. And when they hear that, they will either record it or they will perform some type of action. So in general, it's going to be a single publisher and multiple subscribers. So this is a very popular way to implement things in software. The way that we implement it is usually using a messaging system. If we look over here in the Quokka realm, you can see I've highlighted in red the piece of Quokka that is implemented using this publish subscribe mechanism. And that functionality is our diagnostic functionality where we do port scans and we do packet capture and we do traceroute on demand. So somebody says, hey, I want you to do port scan on this host, or I want you to do packet capture for this type of packet or traceroute to this destination. That becomes a message and it goes through the message broker, and a worker who is listening for it will perform that functionality. So typically we're implementing it using a messaging functionality. The messaging tool that we're using in Quokka Prime is a very popular open source one called RabbitMQ. If you want the details of how to implement this, that's not the point of what I'm talking about here, but I do go into this in the 52 weeks of Python course. So if you look for messaging and RabbitMQ, you'll see a few, at least one, maybe two, maybe three lessons in the long form version on messaging. So you get to learn all you want to know about how to implement messaging, and specifically I'm using RabbitMQ in that situation. So what is it good for? What is the use of this PubSub type software design pattern? Well, one of the things that it provides you for, as you can see down here at the bottom, is loose coupling. So imagine this port scan is, you are unable to do it in Python, but you can do it in some other type of language, or maybe using some piece of hardware somewhere. How can you implement that? Well, If you use messaging, because of the fact that all you really need is somebody to listen to the messages, then you have loose coupling inherent in a messaging system. So you are able to have listeners for that can be implemented in whatever language, in whatever manner you want. You can even integrate it with other existing systems, and all they have to do is listen to the messages that you publish that they will then listen to. So loose coupling is something that you can achieve. What about scalability? What do I mean by that? Well, in some implementations, what will happen is a message will get put onto the message queue, and a worker will retrieve it and then will go off and do it. Now, what if you had, instead of single messages like what we're talking about, what if you had 100 messages? Well, if you have 100 different workers, then each of these workers will receive one message, and they will then be able to go off and do that. So you've achieved concurrency by using a messaging system and having this publish subscribe type of architecture. So scalability is greatly enhanced by the way of doing this. And by the way, notice if you're using a message broker, these workers can be running anywhere. They don't have to be running on the same system that the message producer or publisher is running on. So you can publish things, and these workers can be running on different systems. In fact, the way that we've implemented this in Quokka Prime, quite often you have Quokka workers that are running on a different system entirely. And so you're able to achieve scalability in that way as well. And the last thing that I want to mention is this is a form of an event-driven architecture. So down here, this is basically event-driven. These workers are just sitting around twiddling their thumbs, doing absolutely nothing until a request comes in. What we call that is an event-driven design. So basically, your workers are waiting until an event occurs. And when that event occurs, which we see through the message broker here, then they begin to take action. So if you think about it, a lot of Quokka is implemented as sort of an event-driven architecture. You have events that may come in from users that are going to make requests, and those come all the way down here, and they end up manifesting as a port scan or packet capture or trace route. So those are things that happen. Other events, really, these monitors themselves are actually on their own, running autonomously and doing things on their own, but they're effectively, when they make REST calls, they're sending information to the Quokka server. The Quokka server itself could be acting on this if it chose to do so. So event-driven can be implemented in multiple ways, but in the way that we're talking it here with publish subscribe, you can see quite easily that these workers are just acting based on events that occur, and those events come in the form of messages. So publish subscribe, also known as pub sub. You have a single publisher, you have multiple subscribers who are listening. I don't think I mentioned this, but maybe I did, your subscribers can be completely listen only. In other words, they take no actions. They could just be recording things. Logging systems are quite often that way. So you can have multiple subscribers that take action, or that maybe are just listening. That's publish subscribe. Typically, it's implemented via a messaging system of some type, and it achieves for us loose coupling, scalability, and an event-driven design. Thanks for listening. I hope that makes sense. As always, if you do have questions, just let me know. Thanks.